Hello everyone, welcome back to my tutorial. In this tutorial, we are going to solve 2D heat conduction problem using salome. Salome is the free and open source software. It has a finite element analysis solver called aster. So now we'll open the salome. I have kept salome file here. You can see it. So we'll open this file using terminal. So this is the command to open the salome. Press enter. Just wait for a while, it will get open. Now we'll see our case. So salome 2022 got opened. So this is our case. A 2D plate of 10 meter length and 20 meter height. 3 sides having temperature of 100 degrees Celsius. And top side have a temperature of 200 degrees Celsius. The plate having a thermal conductivity is 401 watt per meter Kelvin. Our aim is to see how temperature is getting propagated inside the plate. Now we'll go for salome, go to geometry model. Here also you can go. Now we're just going to geometry model. First we need to model the geometry. Just go to the case. So we just want to create a plate of 10 meter and 20 meter. So just go to new entity, basics. There is option called 2D sketch. Just choose it. Just go into the rectangle. This is 0, 0 coordinate. Here x is 10, y is 20. Apply and close. Now just click this icon to fit the screen. This is our model. This is actually a line. We just want to build face inside the line. Select the sketch one. Go to new entity. There is an option called build. Choose face. Save OK. Now we have generated the model. Next we need to create a groups to apply the boundary conditions. First group is 100 temperature, another second group is 200 temperature. Only two groups is enough. Just go to the model, select this face one, right click. There is an option called create group. Now we just select the edge group. We need to create an edge group. Select this first edge, press the shift and select the second edge and third edge. Now we have selected these 3 edges. Just add it here. This is the edge number. It will add here. Now we need to name it as 100 temp. So remember it, we should not use space. So we need to use underscore or without space we need to name it. Just apply it. The second group is this edge. Add it as a temperature of 200 temp. Done. Now we have created both the groups. This is a face. If you want to create face group also, we can go for create group, face, select all. This is, we can name it as plate. Just apply and close. Now we have created geometry, then we have created the groups to apply the boundary condition. Now we just save this file. Just saved it. Now we just want to move it into mesh. We need to convert this geometry into finite element model. Go to mesh. Now we are in mesh model. Select the face one. Go to mesh. Create mesh. Here we can choose number of algorithms. Triangle, 2D mapped quadrangle, 2D free quadrangulation. What I am going to do is I am going to set algorithm separately. So 2D I am going to choose quadrangle mapping. In 1D I am going to choose wire discretization. Here in hypothesis, just go here, I am going to choose local length. So here I am going to specify it as 0.5. Say OK, apply and close. Now here you can see the mesh one is created, but it's not completed. Just right click the mesh one, complete. Now this is the mesh information we have. We have created 800 quadrangle element and edges are divided into 120, and we have 861 nodes. Just close it. So these are linear element. If you want to convert this linear into quadrangle, select this mesh one. There is an option called modification. Here the convert to from quadratic. Choose to convert to quadratic. Just apply and close. Now we have converted this linear element into quadratic element. If you want to check it, just go to modification, add node. We are not going to add a node. To view the nodes, this way we can check it. There is one more node which is added in between the edges also. So this is the quadrangle element. To get better accuracy, we need to use quad. So now we have created the mesh and we have taken the groups also into the mesh. Then we need to go for solver. Just go to mesh. There is an option called aster study. Directly we can click this icon also. I'm just choosing aster study. Just save OK. Now we are in the aster study module. Just right click this current case. There are different options. We can add a stage by one also. Now I am going to use wizard. Add a stage with the assistant. This case is a linear thermal analysis. So choose the linear thermal analysis. What it will do, the wizard will only solve 2D and 3D mesh. One thing. Second is it will apply only a constant temperature boundary condition and constant heat flux at the surfaces and volumetric source. Only these three groups boundary condition only it will apply. So ours is a constant or imposed temperature boundary condition. So we can use this wizard. Now just go to next. So this is the mesh one. Go to next again. This is not 3D mesh, actually this is a 2D mesh. Choose plane. Next. In our case the thermal conductivity is 401. Choose, just enter 401. Say next. Imposed temperature on the groups. Just use the icon to add the groups. First one is 100 temperature. Second one is 200 temperature. So 100 temperature, the degree Celsius, 100 degree Celsius. 200 is 200 degree Celsius. Now we have applied the boundary conditions. Just go to next. There is no heat flux. Just give no. There is no volumetric heat source also. Just give it no. Just next. Specify the output result files. Just browse the just go to pictures, code aster. Just provide some name. I'm just giving result.rmed. Result MED format. Just save. Then finish it. So whatever the wizard it will do all things by easy way. So it reads the mesh, it assigns the finite element model, here defines the material, assign the material to the mesh, load ST is nothing but boundary conditions, analysis, this is a linear thermal analysis. The solver name is thermal linear solver. Then output it saves the results in output format. This is the MED format. It has done everything. Now we can save this file, we can solve it. So just go to history view. There is a icon called plus. Just click this plus button. Here at the bottom you just select this one. Auto refresh 5 seconds. Then just run it. Before running you can change this solver also. I just want to, if you want to use more memories, it will solve very quickly. You can specify the time also for your case. 15 minutes is enough, is more time for my case. Always we need to specify the time required to solve the case is be more than the time actually required. So now we can solve this case. Just run it. Here we can view the message file. Now it's reading the command file. Now it's solved. Now you can see here it is the case is coming with the green with tick mark. That means there is no error and error message. Here also you can see it. Diagnostic job okay. If any error comes, we can read the message file. This is the message file. Here also we can read, or directly we can go for message file also. This will directly open the message file. If any error comes, we need to rectify the error by reading the message file. Now we have solved the case. Just save it. We can view the result using paraview. Just go to paraview. Right click it here, open, home, pictures, code aster. Just this one is the result file. The results are stored in this result.rmd file in that format. Just say OK. Now just apply it. Now it came. Now just go to temperature. So this is the temperature profile. If you want to change the color pattern in different color, here you can change it. For example, this one. So high temperature to low temperature it comes. Or if you want to see it in the rainbow, red to blue, blue to red rainbow, just apply and close. Here all the edges are in 100 degrees Celsius. This top edge is 200 degrees Celsius. From 200 degrees Celsius, its conduction happens. Now we can change this into some 12. So this is the way propagation is happening. Example, if you want to plot temperature along this vertical line, we can plot it by using a plot option. Go to filters, search, just type plot. Here there is an option called plot data over time and plot over line. This is a steady state. There is no time variable. Now we can plot over line. Just select this plot over line, enter it. It takes the line this point to this point. Now we can set it y-axis. Just apply it. Now it is X array name is the X array name is actually y coordinate, white points, and y array name, the another parameter is temperature. So X data is the length. So which one is this is 0 point and this one is the 20 height. It takes here you can see 0 to 20. And temperature from 0, temperature is 100 degrees Celsius because we are specifying the constant temperature of 100. And this side we are specifying 200 degrees Celsius because here it's 200. So the temperature is reducing from 200 to 100. This way it's reducing. So in that we have completed this 2D plate conduction problem. Thank you for watching my videos. Please subscribe my channel for more videos. Thank you.